Hi everyone, we are Savannah, Alicia, Lillian, and Sarah, and for our ES-123 project, we studied the effects of glycerol properties and its interactions with water. Before we begin, let's talk about the different properties of glycerol. Glycerol is a byproduct of soap manufacture, and it's primarily used as an emollient. The table here compares the different known chemical properties of glycerol and water. We see that glycerol has a higher molecular weight, density, and viscosity than water, but water has a higher surface tension. Glycerol's viscosity is higher because it contains some hydrophobic bonds, increasing its viscosity. To study the implications of these properties, we dropped a fluid into another fluid. We analyzed 6 different solutions with varying water to glycerol ratios. Red food coloring was added for easier observation. As you can see, water drops from the syringe at a faster speed than the glycerol does and is visibly less viscous. Let's see how our droplets enter a body of water. The droplet does not completely integrate with the body of water upon immediate impact, even if the droplet is 100% water. So what if it has glycerol? Falling droplets stay together on impact due to the Navier-Stokes principle. This droplet in particular stays intact longer than the pure water because adding glycerol to the droplet increases its viscosity. Again, we see these properties in our 100% glycerol solution. The effects of viscosity are significantly more noticeable here, causing our droplet to look like a pancake. Watch how both droplets have a thin layer of air surrounding them as they are entering the water. This air film can be represented by the boundary layer condition we've learned in class. This diagram visualizes the effects of the air film between a falling droplet and the fluid it's being dropped into. The phenomenon prevents the droplet from immediately dispersing on impact, and we see this condition being met across samples. Let's take another look. If we were to compute the Navier-Stokes equation and solve for change of velocity over time, we would first need to simplify the equation by ignoring unnecessary parameters. For example, we can ignore the changes in pressure. Before we establish the proper scientific methods, we had fun dropping various dining hall fluids into water. Here we see that honey most closely represents glycerol, given its highest viscosity. Oh, and the ranch was pretty cool too.